Today's lesson, 3-5, is systems of equations with three variables. When we have three equations with three variables, also known as three unknowns, we're going to do some of the same things we did when we had two equations and two unknowns or two variables. We're just going to expound on that a little bit further. It's a little bit more complex, but it's still just multiplying and adding two lines together, and hopefully one of your variables gets eliminated. We just have to do it more often than we did when there was only two equations with two unknowns. So let's go ahead and get started with that. So if you remember from geometry, when we had two variables, that's two-dimensional, that means it's a line. When we throw in a third variable or a third dimension, we have planes. So what we're trying to do when we have three equations with three variables, we're trying to see where those three planes intersect. And what we really want to have happen is to have it intersect at a point like this down over here in the bottom left. There are ways that we would get no solution, and you see those along the top, and we have a way that we get infinite solutions, but I'm not going to lie to you, we're not going to do that here in Algebra 2. So all of our problems will end up with one point, x, y, z, where the three planes will intersect. So like I said, we could use the same methods that we did over here with the system of equations when we had two variables. Remember, the two things that we did were substitution and elimination, which I like to call the addition method. I will tell you that I'm not a big fan of doing substitution method, especially for three variables. I am a much bigger fan of doing the elimination method, where we add the two lines together and hopefully one of our variables disappears. Well, maybe not hopefully, it has to disappear. So here's a little example of, just to refresh your memory, but we're going to do the same thing with three variables. So here we have a system of equation with three variables, x, y's, and z's. Remember, the first thing you want to do is make sure that they're all lined up, x's above x's, y's above y's, so on and so forth. And then you have to look at the variables and see which one you want to get rid of. You can get rid of any one that you want. You can eliminate the x's, the y's, or the z's. But once you make a choice, you have to stick with that choice. So if you want to choose x's, that's cool, but you'd have to multiply by negatives. So getting rid of the y's or the z's is probably the best way. So what I'm going to do is I'm going to get rid of the z's. So I have to pick two of the equations and add them together, and hopefully the z's will go away. So I pick the 1 and 2, and I've lined them up, and now we're just going to add those together. Get 2y, I don't know why I skipped x, we've got 3x plus 2y equals 15. Let's go ahead and label that equation number 4. For my second set of equations, I chose 1 and 3, and when I add these together, something really crazy happens. The z's and the y's cancel out, and that's not a bad thing, because now I can solve for x right away. I can get x equals 3, and I've got 1/3 of my equation, or 1/3 of my answer. So now we just have to work backwards, and then I can come over here to the fourth equation and go, all right, let's substitute a 3 in for the x, and we can solve for y. We get 9 plus 2y equals 15. Subtract the 9, get 6. We get another 3. Look at that. We got 2/3 of our answers. Now we have to go back to one of the top three equations, 1, 2, or 3. Substitute in your x and your y and solve for z. I'm going to choose 1 because the z is already positive. So let's go ahead and put all that in there. And I get 6 minus 3 plus z equals 4. Subtract the 3, you get 3 plus z equals 4. Better put some lines on my z so you guys don't think they're 2's. And I get z equals 1. So where you're going to put your answer, you're going to make a big parenthesis this time, put them in alphabetical order. X comes first, y comes second, z comes last. And there is the solution to the system of three equations. Let's try another one. So here we have our three equations. Notice they're numbered 1, 2, and 3. I want you to do that every time you do a problem like this. And I have my x's and y's and z's lined up. The numbers are all on the right-hand side. So now we have to decide, what do we want to get rid of? Do we want to get rid of x's, y's, or z's? I look at the z's and I see that they're all positive. So that's not maybe the best choice, but I could do that if I wanted to. But the x's have opposite signs, the y's have opposite signs. I'm going to go ahead and say, let's get rid of the x's. So I'm going to pick equation 1 and 3, and I'm going to add those together. So when I add these together, the x's will cancel out. I get a negative y plus 3z equals 13. And that is my fourth equation, and I label it with a 4. So now I got to pick two different equations and add those together to get rid of the x. So let's go ahead and choose 2 and 3 this time. But notice, if I add 2 and 3 together right now, the x's aren't going to go away. So I'm going to have to do something special to equation 3. So what I had to do is I had to multiply the third equation by a positive 2 so that when I line up my x's, when I add these together, they will cancel out. So I multiplied every term by 2, and now I'm going to combine these, and I get negative 3y plus 5z equals 27. Unlike the last one, I still have an x and a y. So now it's just like we did before. I'm going to line these two guys up and see what happens if I just add them together. Hopefully something's going to disappear. And I'm noticing that if I were to add these two guys together, they don't just disappear. So I'm going to have to pick one of these one of these variables to get rid of. I can get rid of the x or the y. It doesn't matter. I'm going to choose the y because I can turn them both into 3's. All right, so I'm going to put a 3y here and a 3y here because I can turn them both into 3's. I need one of them to be negative, so I'm going to choose the bottom one to be negative. Well, the bottom one is already negative, so I don't have to change the bottom equation at all. So I just rewrite that one over here. But the top one, I have to multiply every term by a negative 3. All right, that's going to give me a positive 3y, a negative 9z, and a negative 39. And we add these together, and I get negative 4z equals, what is that? Negative 8, and z equals 2. I'm a little excited that it came out an integer because that's kind of a hint that I've done it right. If I give you one on the test or in homework that the answers are fractions, I will tell you. Otherwise, they're always going to be integers because it's a lot of work to do to get a fraction and then end up being wrong. All right, so here is one of my answers in my ordered triple. I could come down here where I'm going to put my answer, put x, y, z, and I can already put the 2 into the z spot. So now I have to go back up to either the fourth equation or the fifth equation, put a z in there. I'm going to go to the fourth equation. So I got negative y plus 3 times 2 equals 13. Negative y plus 6 equals 13. Negative y equals 7. Y equals negative 7. Okay, so now there's a second answer. I can come over here, put negative 7. Let's do one more with the x. I'm going to choose equation 1. X plus negative 7 plus 2 times 2 equals 3. And then we got, what's that? X minus 3 equals 3. So x equals 6. So there we have our answer. 6, negative 7, 2. All right. As you can see, it takes up a lot of space. You have to be really careful to show your work, to show it legibly, to show it neatly, so I can follow it, so you can follow it. And at the very end, when you get your thing, you probably should check your answers to see if they work. I'm pretty confident these have worked, so we're going to call it a day.